Hello, everyone. Thank you very much for coming over to listen to my talk. So this morning, I am going to talk about software architecture, adopting sound software architecture practices to attain or to get smarter AI assistants from your coding assistants, right? So yeah, I'm a senior software engineer at the Linux Foundation, currently a part of the platform engineering team. Born, raised, grew up in Davao City, worked in Silicon Valley for a couple of years, and then came back here. All that to say, Batang Mindanao, Batang Davao, Bisayang Dako, and proud of it. All right. Next slide, please. All right, so let's start with talking about AI pitfalls, right? So I want to start by quoting this guy, very funny guy. Claude 4.5 Sonnet just refactored my entire code base in one call. Next. 25 tool invocations, 3,000 new lines, 12 brand new files. It modularized everything, broke up monoliths, cleaned up spaghetti. None of it worked, but boy, was it beautiful. This summarizes my experience with AI if I leave it to its own devices. Next slide, please. Like, here's one example of an AI pitfall, right? You leave it, you let it do whatever it wants, it's gonna create a God class like this, single class with a lot of responsibilities. You don't need to read this code. You can tell it's bad by the number of indentations that it has there and the number of nested if conditions. And then if you can see this line over here, it says, if promo and inventory is less than 10, just give up, return none, right? That's really bad. Next slide, please. Now I'm gonna give you my explanation or what I think are the reasons why this is the case, right? So you have yourself and the AI coding assistant. Next one. There is this low bandwidth communication protocol that is happening between you and the AI assistant, right? When I say low bandwidth communication protocol, I'm not talking about TCP, HTTP, or any other line protocol that you can think of. I'm talking about this protocol, the one that I'm using right now to communicate with you. Human language is a very low bandwidth communication protocol. When you think about it, how many times have you had this instance where you have this storm of an idea happening inside of your head? You try to communicate it to the outside world, and what comes out, instead of a storm, what comes out is a trickle of ideas, very slow. And then you couple that with these 10 fingers, it's even slower, right? So that, I think that's one contributor. A lot of context is lost because of that. And then when you think about software, it's not just about code, right? Software encompasses requirements, design, architecture, infrastructure, right? Unfortunately, next one, your AI has a very limited context window. I think I'm not sure if I'm up to date, but I think the biggest is like a million tokens or something like that. But even that is not enough to cover, to encompass everything that's needed to fully understand your software. And then, of course, there's the third option here, the tendency for your AI coding system to want to please you, or at least it thinks it's pleasing what you want from it, right? So this is non-exhaustive, of course, but I believe that the combination of these three things results in AI just hallucinating stuff and producing really bad output. Next slide, please. So I'm going to quote something from this very talented guy. He says, "I cannot stress enough how bad the code from these agents can be if you're not careful. While they understand system architecture and how to build something, they can't keep the whole picture in scope. They will recreate things that already exist. They create abstractions that are completely inappropriate for the scale of the problem." This is by Armin Ronasher, creator of Flask, Jinja 2, Click, and a bunch of other libraries that you probably directly or indirectly use on a daily basis. This is from his blog where he states he's been using AI on a daily basis in some of his newer projects, right? And this part here is when he starts to transition from using it to saying, be careful with how you use it. Use it, but be careful, right? Next slide, please. So let's talk about how are we going to use it responsibly. Now I'm going to talk about my experience in the Linux Foundation, in the platform engineering team. We've successfully utilized two software architecture principles. They're nothing new, they're actually been around for some time. So the architecture that we've adopted is clean architecture plus hexagonal architecture, or as we like to call it internally, CleanX, right? The CleanX architecture. This is nothing new. It's been around for some time, but let me show you how we adopted this inside of the team. So I'm going to start from a conceptual level. We'll just talk about concepts first, and then after that, we'll dive into the use of it in the context of Python, right? So in the CleanX architecture, you start with the domain layer. In the domain layer, that's where the business rules reside, right? So if I'm talking about business rules, let's say we're talking about an order management system, right? We have an order, and we have order items. One business rule could be the total of an order is the sum of the total of each of its items, right? That belongs in the domain layer. The next layer around that is the application layer. The application layer will serve as the coordinator or the orchestrator between the outside world and the domain layer. In order for it to orchestrate that, it must receive and send signals to the outside world. So these signals can be obtained via the ports. So the ports serve as inputs and outputs, right? And then the next part over here, the next part is over here outside of the application layer. This is what we call the infrastructure layer. Part of the infrastructure layer are the entry points, which you can probably guess is where stuff go in, and the application can also respond. And then on the other side of the infrastructure layer are the adapters. That's where the application layer can send data for persistence, or it can send data to other services, to other systems that might need that information to do something, right? So this is a conceptual overview of the CleanX architecture. Let's now look at how we would implement that in Python. Next slide. So let's start with the domain layer, right? The domain layer is composed of, in this example, the order and order item entities, right? What does that look like in Python? So I hope you can see that from behind, from all the way to the back. But the domain layer code is really just two classes in this case. We have lines 4 to lines 13 is the order class. It's very simple. It just has an ID field, string, customer name is string, and items. The items field is just a list of order items. And then the order item is just another simple class here, right? And then the business rule that I mentioned earlier, which is the total of an order is the sum of the total of each of its order items, which you can see encapsulated here in the total method, which says return the sum of the total of each item in the items list. And the total of each item is also encapsulated here, which is just the product of its quantity and unit price. One thing you will notice in the domain layer, this domain layer specifically, is that it doesn't import anything special. It just imports from standard library. That's usually your signal that you've designed your domain layer properly, is that you're not importing anything outside of standard library. If you're starting to import something, you better question yourself if you're doing the right thing, right? And the side effect of that, of course, is because you're using very simple data types here, then you can probably imagine unit testing this is actually quite simple, right? All right, let's move on to the next part. So let's talk about the order service in the application layer, right? So the order service is the coordinator between the infrastructure and the domain layer. Its method that it exposes is create order. And on the other side, it talks to an abstract class there called order repository, which has a method called save order, right? So what does this code look like? Order service is also quite simple. It's just an ordinary class. It has an initializer where it receives a repository object of type order repository, and it just assigns that to its repository attribute. But that's simple enough. The meat of this class is, of course, in the create order method, where it just accepts customer name and a list of dictionaries, which represent the items that you need to add to the order. And the way it instantiates the order, just simple. Create an instance of the order class, supply it the customer name, and lines 12 to 13, it just iterates through the items and adds it to the order via the add item method. And then on line 15, that's when it calls the right side, of the infrastructure layer, right? It calls the repository's save order method. Again, pretty simple. It doesn't import anything special, right? It's just within the domain layer or standard library. And again, you can imagine how simple it is to unit test. Now you might be wondering, what does that order repository look like? That's just an abstract base class, right? It just looks like this. Order repository imports or inherits from ABC, and then the save order is, well, like that. It just accepts an order object. Doesn't have any implementation because it's an abstract method, right? So that's it. That's the application layer. Let's move on to the next one. Then we're going to start talking about the infrastructure layer, which implements the order repository port, right? So this is the part where we start dealing with actual infrastructure, right? So let's look at what that might look like. This one is admittedly not scalable. I wouldn't recommend this in production, but for demo purposes, this is what it could look like. The JSON order repository, if you look at the initializer, it just defaults to orders.json. So it's going to manipulate that file. So when the save order method is called, lines 10 to 11 will just open that file and load that into an orders object. Line 13 is where it appends the order that was supplied in the arguments. And then lines 15 and 16 just writes all of that back to the JSON file. Again, not production ready, but it's for demonstration purposes. All right, let's move on. And finally, we have the CLI, which is one of the entry points. What could this CLI entry point look like? Next slide. It's just an ordinary function, a create function, and we're decorating that with a click library, where we say what are the arguments that we expect from the CLI, right? But inside of the function itself, we're just instantiating the order service, giving it the repository that's configured for it by the environment. And then we're just calling its create order method, the create order method of the application layer, providing it the information that was given to us by the command line interface. Again, pretty simple, well-defined, and also very testable. Next slide, please. So what's the advantage now of this, aside from it being readable from the human, from the human eyes, right? One advantage to this is that when you start working with your AI to, implement this or work with this, because the boundaries of each of these layers are very well defined and quite simple. For example, the boundary between the entry points and the order service is just that create order method with very simple parameters. Then you can be sure that if you let your AI focus on this part over here, it doesn't need to worry about that part. There's less chance of hallucination, less chance of it, creating God classes or whatever else. And same goes for the, if you wanted to focus on the middle layer or on the right side, all right? Next slide, please. So I didn't pray enough to the demo gods today, so I will not have a live demo, just sample code. If you go to my GitHub account, Relax Diego, and you look for PyCon Davao 2025, I have this demo code based on what I presented. There are 3 branches over here. The main branch, there's the bad example output, and then the good example output. Feel free to check that out if you want. If you want to learn some more about how Kleenex helps with cleaning up your AI's output. All right, for further reading, I would highly recommend Bob Martin's Clean Architecture. There's also Alistair Coburn's Hexagonal Architecture article. And then if you want a more Python-centric introduction to all of these concepts, I highly recommend Architecture Patterns with Python. Chapters 1.5 were very nice, in introducing this to newcomers. Next slide. Now I want to end with this, another, from the same article by Armin Renscher. The tools are powerful, but they don't absolve you of responsibility. Always remember, you are the expert of your software. The AI is your subordinate. It's a very fast grunt worker if you must. think I killed, okay. All right, think that's it? All right, thank you.